Hello guys, now in this video we are gonna talk about equation of a plane. So the objective of this video today is to define the normal of a plane, to find the equation of plane defined by three non-collinear points, to find the equation of a plane defined by point and line, to find the equation of plane defined by two intersecting lines, and finally to find the equation of a plane defined by two parallel lines. Now, what is the normal of a plane? A plane is characteristic by point and a normal. The normal vector of a plane is the vector which is perpendicular to any vector in this plane and to any line in this plane. For every plane there exists at least one normal vector which is confounded or parallel. It means that we have an infinite number of normal vectors of a plane. In this figure, let's see the plane QSR, and n is the normal vector of the plane QSR. We see that this vector is perpendicular to QS and QR and SR and to every vector in this plane and to every line in this plane. To find a normal vector of this plane, we need to find the cross vector between QS and QR, since the cross vector of QS and QR is a vector perpendicular to QS and perpendicular to QR. Now let's talk about equation of plane passing through three non-collinear points. The Cartesian equation of plane is ux plus by plus wz plus r equal to 0, where the normal vector is u, v and w. So an equation of plane defined by three non-collinear points. We know that three non-collinear points form a plane. To find the Cartesian equation of this plane, we have two methods. First method, step 1, we need to take a variable point on the plane P, so let m, x, y, z be a point on the plane P. Step 2, we need to find a normal vector of this plane. In this case, a normal vector is AB cross AC. It's one of the normal. Step 3, by solving the scalar product am dot n equals 0, we give the equation of plane P. Since the normal is perpendicular to any vector on the plane and am is a vector on this plane, so am dot n equal to 0. So by solving this equation, we get the equation of plane P. This is the first method to find the equation of plane P. We have another method. Also, we need to take a variable point m, x, y, z on the plane P. Step 2, we need to find also a normal of this plane. In this example, we see that the normal is equal to AB cross AC. Give the coordinates. This vector is the normal vector of the plane, then its coordinates are u, v, w. Step 3, we need to just find r to find the equation of this plane. By substitute one of the 3 points A or B or C in the equation of P, we get R. Let's go to an example about this. The question is to find the equation of plane P determined by A, B and C. Every plane defined by point and normal. A point on the plane P, it's A. We can take B or C. A normal is the cross product between two vectors in this plane. By example, we can take the normal and it's equal to AB vector cross AC vector. Let's find this normal AB vector cross AC. Put them in the form of a matrix. The first row IGK, in the middle the vector AB, and last row is the vector AC. By calculation, we get the normal vector minus 6j minus 4k. Now we need to take a variable point on P, it's x, y, z, then AM is perpendicular to the normal vector n, so AM dot n equal to 0, where AM it's xm minus xa, ym minus ya, zm minus za, and the normal vector is 0, minus 6, minus 4. By solving this equation, x prime plus y prime plus z prime, we get the equation of the plane P. Now let's talk about how to find the equation of a plane defined by point and line. So for this, take a line D and a point A does not belong to the line D. So this point A and this line D form a plane P. A normal vector of the plane P, it's a vector which is perpendicular to two vectors in this plane P. So for this, we can take a point B on the line D. Then the normal vector of the plane P is the cross product between vector AB and V, where V is a director vector of the line D. Let's go to an application about this. So we can take a straight line D of parametric equation x equal t, y equal t minus 1, and z equal t plus 2, and take a point A with coordinates 0, 0, 4. The question is to show that A and D form a plane with equation to be determined. A and D form a plane if A does not belong to D. Then we need at first time to show that this point A does not belong to D by replace the coordinate of A in the equation of D, replace 0 by x, 0 by y, and 4 by z. We get t equals 0 and t equal 1, which is impossible. Then A does not belong to D, so A and D form a plane P. Now we need to find a normal vector of the plane P to find its equation. Every plane defined by point and normal. So a point on the plane P is A, and a normal to the plane P is the cross vector of two vectors on the plane P. Then n is equal to AB cross VD, where B is a fixed point on D and V of D is the director vector of D. So we need to find this fixed point. We can take t equals 0 by replace t by 0 in the equation of D. We get x equals 0, y equal minus 1, z equal 2. It's the point B, and we can calculate now the coordinates of the vector AB by xb minus xa, yb minus ya, zb minus za. We get the vector AB. We need now a director vector of D. 1, 1, 1 is the director vector of D. So the normal, it's equal to AB vector cross VD vector. We get n minus 1, 2, minus 1. Then this is a normal of the plane P. Now take mxyz be a point on the plane P. Then the vector AM and the vector n are perpendicular, so AM dot n equal to 0, where AM is xm minus xa, ym minus ya, zm minus za. By solving this equation, x prime plus y prime plus z prime equals 0, we get the equation of the plane